Hey guys, welcome back to my channel. We're continuing with the playlist for IGCSE Edexcel Maths A. Today we're going to do Surds. So in this video, we're going to do the easy level questions for Surds, and then I'll make a separate video where we're going to do harder questions for Surd, where they're combining like a different topic with Surds. For example, there's like volume and surface area, or trigonometry combined with Surds, or even differentiation. Depends on like what the question is about. So there's a separate video for that. And in this one, we're going to understand how to solve surds using the basics. So when you're expanding brackets with surds, when you're rationalizing the denominator, or when you're prime factorizing a surd to simplify it. So let's start with the first one. It says root 3 times x minus 2 root 3 equals to x plus 2 root 3. Give your answer in the form of a plus b root 3, where a and b are integers. So you have to find the value of x. So let's expand the bracket first. So it's going to be x root 3 minus 2 root 3 times root 3 equals to x plus 2 root 3. X root 3 minus, when you multiply root 3 with root 3, basically we're squaring it. It's the same as 2 square. 2 square is 2 times 2. So root 3 square is root 3 times root 3. So you need to remember that when you're squaring a surd, like when you're squaring a root something, the root cancels out. So when the root cancels out, it leaves us with 3 over here for root 3. So square of root 3 is 3. Square of root 5 would be 5. So the square and the root get cancelled out, and we're just left with the number inside the surd. So it's x root 3 minus 6 equals to x plus 2 root 3. Now we collect like terms on each side. So x root 3 minus x on one side and 6 plus 2 root 3 on the other side. Take x common. That's root 3 minus 1 equals to 6 plus 2 root 3. X equals to 6 plus 2 root 3 divided by root 3 minus 1. They want the answer in the form of a plus b root 3, which means we need to rationalize the denominator now. So in this question, you're learning two things: expanding brackets with surds, and now rationalizing the denominator. When you're rationalizing the denominator, and if your denominator is, let's say, root 3 minus 1, as in this case, what you will do is you will multiply and divide it by the surd in the denominator, but now the sign is going to be opposite in the middle. So if it's root 3 minus 1, you multiply and divide the fraction by root 3 plus 1. If it was root 3 plus 1, you would multiply and divide by root 3 minus 1. So the sign in the middle changes. That's the only thing that changes. Otherwise, it's the exact same thing as the denominator. This is very similar to like when we're adding or subtracting fractions with unlike denominators. If you remember, in that case, you multiply both the numerator and denominator with the same number when you're making the denominators equal to add or subtract the fractions. So same concept over here, you're multiplying and dividing the fraction by the exact same thing. So if you multiply it by root 3 plus 1, you divide it by root 3 plus 1 as well. Next is we multiply the numerator with the numerator and denominator with the denominator. So that's going to be 6 times root 3 plus 1, and then plus 2 root 3 times root 3 plus 1 divided by root 3 minus 1 times root 3 plus 1. Six times root 3 is 6 root 3. 6 times 1 is 6, plus 2 root 3 times root 3 is 2 root 3 squared, and then plus 2 root 3 divided by, now in the denominator is root 3 minus 1 times root 3 plus 1. By now, you must know about difference of perfect squares. In difference of perfect squares, we're subtracting two square numbers. So when you expand those, so when you factorize those, that is a minus b times a plus b. So a square minus b square equals to a minus b times a plus b. Over here, they've given us the a minus b times a plus b form. So we have to rewrite it as a square minus b square. So that's going to be root 3 squared minus 1 squared. If you want to expand the bracket, you can also do that. But to save time, you can just simply rewrite it as root 3 square minus 1 square because it's difference of perfect squares. So now 6 root 3 plus 6, 2 root 3 square is 3. So 6 root 3 plus 6 plus 2 times 3 plus 2 root 3. Root 3 square is 3, 3 minus 1. 6 root 3 plus 2 root 3 is 8 root 3. When you're adding or subtracting sets, you can only add or subtract them if the number inside the root is the same. So since 3 and 3 are the same, so we can add them and that gives us 8 root 3. 2 times 3 is 6, so it's going to be plus 6 over 2. So it's 8 root 3 plus 12 over 2, which simplifies to 4 root 3 plus 6. So that's your final answer. In this question, you learned pretty much everything that's going to come in Surds: expanding brackets, rationalizing the denominator, and how to use difference of perfect squares to make your calculation easier. In this one, it says root 20 plus root 80 can be expressed in the form of root a, where a is an integer. Show your working clearly. So in this one, you learn how to simplify a surd. So we have root 20, we have root 80. So we know 20 can be split into 4 times 5. And 4 is 2 times 2. So why don't you rewrite root 20 as 4 times 5? Now for 80, 80 is 8 times 10. 8 is 4 times 2. 10 is 5 times 2. So if we rewrite this as 4 times 2 times 2 times 5. 3 is already a prime number, so we cannot further break it down. So square root of 4 is 2. So the 4 comes outside as 2 and the 5 remains inside the root because we cannot take its square root. Over here, again, the 4 comes outside as 2 and 2 times 2 is 4 again. So this 2 also comes outside. So now we're left with 5 inside the root. So 2 root 5 plus 4 root 5 over root 3. Since the number inside the surds are the same, so we can add 2 and 4. So that's 6 root 5 over root 3. Nothing is happening to the number that's inside the surd when you're adding or subtracting. What changes is the number outside. So next step is to rationalize this now. So to rationalize this, I'm going to times it by root 3 and divide it by root 3. In the previous question, we had root 3 minus 1 in the denominator. So we multiply it and divide the fraction by root 3 plus 1. Over here, it's just root 3. So when it's just root 3, you just multiply and divide the fraction with that. So that's going to give us 6 times 5 times 3 root over root 3 squared. When you're multiplying surds, you just combine the surd under one root and you multiply the numbers inside the root. So root of 5 times root of 3 is root of 5 times 3. So that's 6 root 15. And square root of root 3, we've already discussed that, that's going to be 3. 6 divided by 3 is 2, so 2 root 15. You cannot divide the number inside the root by a whole number. You cannot do anything to it. You can only simplify it if possible. Otherwise, it stays as it is. So when I divide 6 root 15 by 3, I only divide the 6 by 3. I don't do 15 divided by 3. That's not becoming 5, it's 15. So remember, you're dividing the number that's outside the root with the divisor. You're not dividing everything. The root remains as it is, but 6 becomes 2 because 6 divided by 3 is 2. So that's how you will solve this question. In this question says root 3 whole power 5 equals to k times root 3, where k is an integer. Find the value of k. So to figure out the value of k, You need to realize that we're multiplying root 3 5 times over here because it's root 3 to the power 5, which means there were 5 root 3's being multiplied. So if we combine them under one root, it's 3 times 3 times 3 times 3 times 3. 3 times 3 is 9, so we have 2 9s and 1 3. In the final answer, there's just 1 3 inside the root. And as you can see, we have isolated that 3 because 2 3's make a 9. So we have 2 sets of 3's and 1 single 3. And as we know, 9 is a square number. Square root of 9 is going to be 3. So this 9 comes outside as 3, and again this 9 comes outside as 3. So inside, we're just left with 1 3. 3 times 3 is 9, so 9 root 3 is your answer, and k is 9. So once again, if it's root 3 to the power of something, that means you're multiplying root 3 that many times. So first, we wrote root 3 to the power 5 as 5 root 3's being multiplied. Then I combine those 3's inside one root because it's pretty much the same thing. We're multiplying the same thing to itself. Then, if we combine two 3's, that gives us a 9. Again, if we combine two other 3's, that gives us 9. So it's 9 times 9 and then times 3. The answer has clearly indicated that they just want 1 3 inside the root in the final answer. So the two 9's, when we square root them, it gives us a 3. So one 9 comes outside as a 3 and so does the other one. So now it's 3 times 3 outside the root, and inside the root it's just 1 3. So that 3 times 3 becomes a 9, and it's 9 root 3. Then it says show that 21 over 3 minus root 2 can be written in the form of c plus root d, where c and d are integers. Show each stage of working clearly. So this is very similar to the first question that we did, where we have to rationalize the denominator. And as I've told you, when you're rationalizing the denominator, you will multiply and divide the fraction by the same thing in the denominator, but you will change the sign in the middle. So it becomes 3 plus root 2 over 3 plus root 2. Exact same thing, but the sign in the middle is different. Now multiply the numerator with the numerator and denominator with the denominator. So expand the bracket, 21 times 3, which is going to be 63, and 21 times root 2 is going to be 21 root 2. For the denominator, if you want to expand the bracket, you can also do that, or you can just simply use difference of perfect squares and rewrite the denominator as 3 square minus root 2 square. Because a is 3 and b is root 2. So that's 63 plus 21 root 2 over 3 square is 9. Square of root 2 is going to be 2. So 9 minus 2. So 9 minus 2 we know is 7. So it's 63 plus 21 root 2 divided by 7. 63 divided by 7 is 9. 21 divided by 7 is 3. Like I mentioned before, you only divide the number that's outside. Nothing happens to the number that's inside the root. In the question, if you notice, it says in the form of c plus root d. So that means they want nothing that's outside the root. So which means we need to get rid of the 3 over here. How do we get rid of the 3? So if you remember when I said over here that it's 9 times 9 times 3, and that gives us 9 root 3. Okay. So if we reverse it, when you take a number that's outside the root and you take it inside the root, we square it inside. So it's written twice inside the root, because when you take the square root of something, you're basically cutting it in two halves. But if you're reversing it, if you're going back inside the root, it's going to be multiplied 2 times. So what happens over here, it becomes 9 plus root 2 times 3 square. When you're going outside the root, you're writing that number once. But if you're going from outside to inside the root, you're writing that number twice. So it's 9 plus 2 times 9, and that's 9 plus root 18. That is your final answer based on the format that they're asking in the question. In this one, it says show that 5 minus root 2 over root 2 minus 1 can be written in the form of a plus b root 2, where a and b are integers. So same thing as we did in the previous question, but now the format is slightly different. So we'll begin with multiplying and dividing the fraction by root 2 plus 1. So numerator gets multiplied with the numerator and denominator with the denominator. So 5 minus root 2 times root 2 plus 1 over difference of perfect squares, root 2 squared minus 1 squared. So 5 times root 2 is 5 root 2. 5 times 1 is 5. Negative root 2 times root 2 is negative root 2 squared. And negative root 2 times 1 is negative root 2. Square of root 2 is going to be 2. 1 square is 1. So that's 5 root 2 plus 5 minus 2 minus root 2. 2 minus 1 is 1. So the denominator is 1. Collect the like terms. 5 minus 2 is 3. 5 root 2 minus root 2 is 4 root 2. And as you can see, the format is exactly the same as in the question. So this is your answer. In the previous case, they did not want any number outside the root. So they wrote it as c plus root d. Over here, they want a number outside the root, so we don't reverse it and put it back into the root. The 4 remains outside as 4. Then it says express root 675 in the form of n root 27, where n is a positive integer. So again, very similar to prime factorizing a number and bringing it down in the form as asked in the question. So what we'll do is we'll break down 675 into its factors. So 675 will obviously be divisible by 27 because they want 27 the root. So 675 divided by 27, that's 25. So 25 is 5 times 5 because it's a square number. So rewrite 675 as 25 times 27. Square root of 25 is 5. So 5 root 27 is your answer, and n is 5. Another trick you can use over here is that they'll always give you a form in the question, like we want the answer in this form. And if they've identified like what number has to be inside the root, you can just begin with dividing the given number by that and then make sure that that number stays isolated on one side and you're breaking down the other numbers until you reach the answer that they want. Given that 8 minus root x times 5 plus root x equals to y root x plus 21, where x is a prime number and y is an integer, we have to find the value of x and y. So let's begin with expanding the brackets. 8 times 5 plus root x, then minus root x times 5 plus root x. 8 times 5 is 40, then it's 8 root x, then minus 5 root x, and then minus root x squared. We can collect the like terms. 8 root x minus 5 root x is 3 root x. Square of root x is going to be x. And this entire thing is equal to y root x plus 21. So what we will do now is we'll compare the left-hand side with the right-hand side and put the similar terms equal to each other. So 40 minus x is the same as 21. 3 root x is the same as y root x. So 40 minus x equals to 21 and 3 root x equals to y root x. That clearly shows that y equals to 3 and x is going to equal to 19. And as you can see, the question said that x is a prime number, so it's a prime number, and y is an integer, y is also an integer. So that meets our conditions. This question says that the area of a rectangle is 18 centimeters square. The length of the rectangle is root 7 plus 1 centimeters. Without using a calculator and showing each stage of your working, find the width of the rectangle. Give your answer in the form of a root b plus c, where a, b, and c are integers. So we know that the formula for area is length times width. And if we're trying to find the width, is basically area divided by the length. So over here, width is going to be 18 divided by root 7 plus 1. Remember, I told you when there's a surd in the denominator, you have to rationalize it to solve it. So that means we're going to multiply and divide this fraction by root 7 minus 1 in order to find the width. So 18 times root 7 minus 1 divided by root 7 plus 1 times root 7 minus 1. Expand the bracket, 18 root 7 minus 18. Use difference of perfect squares in the denominator, root 7 squared minus 1 squared. So that's 18 root 7 minus 18 over 7 minus 1. And that is 6. Now we know 18 and 6 come in the same times table. So 18 divided by 6 is 3. So A is 3, B is 7, and C is also, and C. So A is 3, B is 7, and C is negative 3. This is your width of the rectangle. Then this one says, without using a calculator, show that 12 over root 2 minus 1 minus root 2 to the power 5 equals to 2 root 32 plus 12. So first I'm going to simplify root 2 to the power of 5. So root 2 to the power of 5 basically means 2 times 2 times 2 times 2 times 2. 5 2's. So this is 4, this is 4. So it's 4 times 4 times 2. Square root of 4 is 2. So 2 times 2 outside, and we're left with 4 root 2. So it's 12 over root 2 minus 1 minus 4 root 2. Now after this, we have to rationalize the denominator for the fraction. So that's going to be 12 over root 2 minus 1 times root 2 plus 1 over root 2 plus 1, and then minus 4 root 2 over here. So that's 12 times root 2 plus 1 over root 2 minus 1 times root 2 plus 1 minus 4 root 2. 12 root 2 plus 12 over root 2 squared minus 1 squared and minus 4 root 2. 12 root 2 plus 12. Root 2 squared is 2, so 2 minus 1. 12 root 2 plus 12 and 2 minus. Since 2 minus 1 is 1, so we don't write that, and minus 4 root 2. So 12 minus 4 is 8. 8 root 2 plus 12. Now they want the answer as 2 root 32 plus 12, which means we bring back the 8 inside the root. So 2 times 8 square plus 12. So 8 square is 64. They want 32 inside the root. So 64 is 32 times 2. So 2 times 2 times 32. Since 2 times 2 is 4, square root of 4 is 2. So the 2 comes outside, 32 is inside, and we have our final answer. So remember, you have to read the question very carefully and make sure that you're giving the answer in the format that they're asking in the question. If you don't, they're going to deduct a mark for that. You won't score full marks. And these questions are already like 3 marks questions, so you can't afford to lose marks in this. This question says a equals to root a plus 4 and b equals to root 8 minus 4. A minus b times a plus b can be written in the form of y root 4y. Find the value of y. So let's begin with substituting the values of a and b. Root 8 plus 4 minus root 8 minus 4. Root 8 plus 4 plus root 8 minus 4. Root 8 plus 4 minus root 8 plus 4 times 2 root 8, and 4 minus 4 is 0. So root 8 minus root 8 is 0. 4 plus 4 is 8. So 8 times 2 root 8. So that's 16 root 8. Y is outside and y is inside. So if I rewrite this, that's 8 times 16 square. Now 16 square is going to be 256. They want just 4 inside. So 256 times 8, that's 2048. So if I divide this by 4, that's 512. So 4 times 512. Now we've already isolated our 4, so now we need to break down 512. Now if you break down 512, 512 is basically 8 times 64. And 64 is 8 times 8. So if we rewrite this, it's 4 times 8 times 8 times 8, basically. So 2 8s come outside as an 8, and it's 4 times 8 inside the root. So this is the same as this, which is exactly what the question wanted us to show, which means y value is going to be 8. So for these type of questions, you need to know how to break down the number based on what information that they've given and isolate that number and see how you can further break down the other number to give the answer in the exact form as they're asking for. And with that, we're done with the easy questions for Surds. Some of them were like slightly harder, but like the harder questions are going to come in the next video. I'm going to make a separate video for that. Don't forget to check that out. And if you have any questions or confusions regarding this one, please leave a comment below and I'll help you out. And if you understood everything, do like and subscribe, share this video with your friends because this is greatly going to help in your exam prep.